Okay, the last sections of Chapter 7, the last two sections, empirical formulas and molecular formulas, we are not going to do the calculations with those sections for Chem 110. Those calculations are more so for Chem 121. But I would like to introduce you to those terms, empirical and molecular formulas. And if you plan to take Chem 121, you can refer to the textbook and the calculations. The calculations are molar mass based calculations. So just like we have learned the tools for molar mass conversions, you will use those same tools to do these calculations, but they are not part of Chem 110 to do empirical and molecular formula calculations. But anyway, what are they? Okay, empirical formulas represent the simplest formula, the smallest whole number ratio of atoms of elements in a compound. Simplest terms, okay? You cannot reduce the subscripts to any lower whole number. The molecular formulas, on the other hand, represent the true total number of atoms of elements that are present in a compound. Let's talk about three formulas right here. Let's talk about the CH2O, C2H4O2, and C6H12O2. O6, oops, boo-boo, fix that. O6, sorry. Okay. All right. Let's talk about these three formulas here. Okay. Formaldehyde. Okay. Formaldehyde is used for embalming fluids. It's still used to this day. For anatomy classes, it used to be used as the embalming fluid for the specimens, but due to the toxicity of it, it was replaced with acetaldehyde, something similar. But anyway, this is the empirical and molecular formula for formaldehyde. Okay, so you have 1 carbon, 2 hydrogens, and 1 oxygen. You cannot reduce these subscripts of 1, 2, and 1 to any lower whole number. But this is the molecular formula for formaldehyde. Formaldehyde has 1 carbon, 2 hydrogens, and 1 oxygen. So this happens to be the empirical and molecular formula for formaldehyde. Back in the days of Prohibition, when people were making their own liquor, they weren't making all the time ethanol. They were making methanol. And that alcohol, when it is ingested into the body, converts into formaldehyde, which is toxic to the liver. So it had a pretty bad result in that case, as the body converts methanol into this and the liver cannot process it. So it used to be used in paint formulations as well. They've kind of taken it out because of its toxicity. But that's one substance with this empirical formula. These two substances are very different. They have the same empirical formula, but they have different molecular formulas because they're different substances. C2H4O2 is the molecular formula for acetic acid. Acetic acid is the acid that is in vinegar. Okay, so this is the molecular formula for acetic acid, but if you reduced the subscripts of 2, 4, and 2 to their lowest terms, you would wind up with the same empirical formula that formaldehyde has. Let's look at another formula. Glucose, blood sugar. C6H12O6. Okay, 6 carbons, 12 hydrogens, 6 oxygens. It's molecular formula for glucose. Again, a very different substance than acetic acid and a very different substance than formaldehyde. They're all different substances. But the molecular formula, if you reduced it to its empirical formula, the 6, the 12, and the 6 would be reduced to a 1, a 2, and a 1. So just to explain the difference in terminology with empirical formulas and molecular formulas, empirical formula has the simplest ratio for subscripts, and the molecular formula represents the true ratio of the subscripts for the elements. At times, a molecular formula would need to be calculated, and to have the molecular formula calculated, you would first need the empirical formula. As you take Chem 121, you see we do that in that course. So you would take the empirical formula, and then you would do another step to get the molecular formula. Okay? So no calculations are required for Chem 110 for this these two sections. And that concludes Chapter 7. Okay, if you have any questions about any of the recommended homework problems, please reach out to me so that I can help you. Okay,